on one page because actually they are referring to the same problem. You see, this example 4.2 is about the horse pulling the barge, and example 4.2 is the same. Repeat example 4.2, but they just change the angle to 40 degrees and negative 20 degrees. So they are actually the same problem, right? So I put these two problems on the same page so that you can refer, right? You can refer to them. Okay, so to understand what is the problem all about, please read this example 4.2. Just read.
The two horses are pulling a barge with mass 2 times 10 to the power 3 kg along a canal, as shown in figure 4.8. The cable connected to the first horse makes an angle of theta 1 equal 30 degrees with respect to the direction of the canal, while the cable connected to the second horse makes an angle of theta to about 2 equal negative 45 degrees. Find the initial acceleration of the barge starting at rest if each horse exerts a force of magnitude of 6 times 10 to the power 2 Newton on the barge, and no forces are resistant on the barge.
Okay, so the question is like this. There are two forces here. One is called F1, the other one pulling in this direction, downward direction, is called F2, right? Two forces will produce a resultant force, or sometimes we call it the net force. Resultant force or net force, how to type? Type here. So resultant, okay, it's called a resultant force, or sometimes it's called the net force. Sometimes it's called the net force. Okay. So we are supposed to find this resultant force, the resultant of the two forces, or the net force of these two forces. So to find the net force, we are actually supposed to find when these two forces combine together, what is the magnitude? Of course, this is F1, this is F2, maybe this 600, they say it's 600 Newton, 600 and 600. But 600 and 600 will not produce 1200. The reason is because they are acting in along different lines. They're acting in different direction. So they will not produce 1200. It will be something less than 1200. So how much is the magnitude of that force? Number one. Number two, in which direction is this resultant force, right? So although there are two forces, actually when they combine, it will become another force traveling in another direction, right? The combination of the two. So we are supposed to find what is the resultant of these two forces. Now, there are two ways of finding the resultant force. Okay. Now, these forces, they are actually vectors. So we should treat them as if we are adding vectors and not adding numbers, right? Adding numbers, 600 plus 600 is 1200, but that is not the case because they are vectors, right? So we have to add them as if we are adding vectors, right? So there, as I've said earlier, there are two ways of finding the resultant force. Okay, right. To find the acceleration or the result, the net force, we have to find the net force first, right? Now this net force is actually the vector sum of all the forces acting on the object. So the object is this one, the barge, the boat that carry log, luggage, whatever lah, container, cargo, things like that. But maybe this is in the olden days. That's why they have to use two horses to pull them along. Okay, so to find the net force, we have to treat these forces as vectors, and we have to sum the vectors together, the sum of these two vectors. Now, the first method to find the sum of vector is actually to use the triangle law. We draw one triangle involving the two forces and solve the triangle, right? So we treat them as if they are vectors. So we treat them as if they are the sides of a triangle. Now, in that case, you must know the sine rule and the cosine rule. Now, in this book, they assume that you don't have the knowledge of this sine rule and cosine rule in mathematics. You see what I mean or not? So by right now, when you draw this triangle of forces, you can use sine rule and cosine rule to solve the triangle. But this book says, never mind if you don't have this knowledge of sine rule and cosine rule. So they show another way. Another way is to resolve the forces into its components, right? These forces, you resolve them into the components and find the sum of each component, then combine them back to form the resultant force. Now, I'm going to explain what is meant by this. Resolve them into component and resolve them and add them up again. Okay, right. So the two forces from this diagram, they are F1 and F2. These F1 and F2, they are acting at an angle of theta 1 and theta 2 about the horizontal line. Okay, so let's consider this F1 here, right? So this is my F1. I have drawn it in red color. So this F1, I'm going to resolve it into two components. Okay, F1, the two components, they are this blue color one here, F1 sine theta 1. The other component is F1 cos theta 1. Like I have told you earlier, this is 1 ringgit. This 1 ringgit, which is red in color, you have changed them to two 50-cent coins. So the two 50-cent coins, they are the blue color. So the red color is equivalent to the two blue colors here. So that means you don't have the 1 ringgit note anymore. The 1 ringgit note, you exchange it for two 50-cent coins. The two 50-cent coins, they are F1 sine theta 1 and F1 cos theta 1. So no more red color, just these two blue color. Okay. Then the second force is F2. Again, this F2, I remove this letter first. Okay. Again, this F2 can be resolved into two components. The two components, they are F2 cos theta 2 and F2 sine theta 2. The horizontal component is always cos. The vertical component is always sine. This is the it comes from the definition of the trigonometric ratio. So again, this red color, when you exchange it for the two blue colors, they actually become the two blue colors and you don't have this red color anymore. So what we have now are four components. No more the red color, but the four components. The four components, they are F1 sine theta 1, F1 cos theta 1, F2 cos theta 2, and F2 sine theta 2. So we have four components now. Right. Now, in order to find the resultant force or the net force, I add them up. Those in the same direction, I can add them up. So I try to add them up, right? So the two that are in the same direction, they are these two, these two. F1 cos theta 1 and F2 cos theta 2. So I add these two together. And when I add them together, it's over here. It's over here, right? Add them together. So this F1 cos theta 1, F2 cos theta 2, I add them together. And they are actually the horizontal component of the net force. So the horizontal component of the net force, I call it Fx. Fx. Okay. So the horizontal component of the resultant force is the sum of these two forces. So now you can substitute the numbers inside. So the numbers F1 is 600, F2 also 600, but the angle different. Theta 1 is 30 degrees, theta 2 is negative 45 degrees. So if you take out your calculator, you try to calculate the sum, is it equal to this 944? Cos negative 45 is actually a positive number because the 45 degree, negative 45 is in the fourth quadrant. In the fourth quadrant, cosine is positive. So you will get a bigger number. This one, negative 45. Can you get the same number or not? 9.44 times 10 to the power 2 or 944. Can or not?
I got 95 point something, sir.
95 point something, huh? Okay. You, I tell you, then you type, huh? 600 cosine 30. 600 cosine 30 actually is cosine 30 is root 302. You use the degree mode, don't use the radian mode. Degree mode, because the angles given are in degree.
I don't know. I used another calculator. I got 94.38.
That will be correct. It's 9.
This one, I don't know why I got
The mode,
95.35. I'm
try
in
the
degree,
mode.
sir. I'm
Are
in
you
degree
using the
already.
degree mode?
Yeah, I'm in degree.
Okay, the second one is correct. Okay, so we carry on, we carry on. So this 944 times, no, 9.44 times 10 to the power 2 is actually the horizontal component of the resultant force. So we proceed to find the vertical component. So these two, they are in the same direction. I try to add them up. So in adding them up, it is add up f1 sine theta 1 plus f2 sine theta 2. So I substitute in the numbers. The f1 is 600, f2 is also 600, but the angle is different. The first angle is sine 30. The first angle is sine 30. Okay, the first angle is sine 30. Now this sine 30 is a positive number. Now the second angle, theta 2, is actually negative 45 degrees. Sine of a negative angle will give you a negative number. So because of that, the whole thing becomes negative 424. So when you have this 300 minus 424, you get a negative 124. It means that although one is going up and one is coming down, the result of these two forces is coming down because the downward one is bigger. The downward force is bigger. So you have a resultant force of negative 124. You try and see you can get this number or not, negative 124.
Yeah, I got negative 124. I don't know why
Yeah,
my other calculator I'm not getting the negative 124.
maybe
So
the
weird.
setting. This is negative 124 and this is 944. So this is the final one. This is the final one, right? So the final one is the horizontal component is 944. The vertical component is negative 124. So now we are going to use the Pythagoras theorem to combine them back into the single force. We find them as two separate forces, then we combine them back into this force here. This force here, using Pythagoras theorem, is 952. Okay, so the first horizontal component is 944. The vertical component is 124. So the Pythagoras theorem to combine them back is square root of fx squared plus fy squared. Now, when you use your calculator, you type the square root sign, then you produce a bracket. Okay, inside the bracket sign, inside the square root, you produce a bracket, then you type 944 square plus 124 square. Then you should get the answer. You try and see you can get it or not in one step. Square root bracket,
I got 952. Yeah.
correct. Okay, so now this is the net force. or the resultant force, the red color. The blue component you've combined to get the red one. According to Newton's second law of motion, the net force equals to the mass times acceleration. So we found out the net force to be 952. So I replace the net force here with 952. And the mass is 2000 kilogram. The mass of this batch, the mass of this batch is 2000 kilogram. So acceleration, we don't know. So we try to find the acceleration. That is what the question wants, that we have to find. So to find the acceleration, you use this 952, the net force, divided by 2000. Then you should get the acceleration, right? So it's 0.476 meter per second. So this is the net force that produce an acceleration of 0.476 meter per second. Okay, next, we need to find, although we know the magnitude of this force, the resultant force, but because it is a vector quantity, we need to know also the angle, not only the size of the force, but we must know this angle here. So in order to find this angle theta here, you have to use tangent, right? Tangent. So tangent is the vertical component divided by the horizontal component. The vertical component is negative 124. The horizontal component is 944. Now, how to use your calculator to find this? First of all, you use, I miss out the negative sign. You use negative 124 divided by 944, and you see what is your answer. Make sure you switch to degree mode. You switch your calculator to degree mode, then you use negative 124 divided by 944. What's the answer? Negative 124 divided by 944.
Negative 0.131.
In physics, they are very particular about the places, the significant figure and the decimal place. So you round off to 0.1, negative 0.131. Okay, so you leave the answer negative 0.131, then you press tangent shift tangent of this number.
Yeah, got the number. I put in the full number. I did not round it up. They gave me negative 0.4, negative 7.48. So I got to put negative 0.131 to get the negative
Yes,
7.46.
you are right. You are right. So they are very particular about this rounding off. Okay, so you get negative 7.46, and this is the angle coming down. Okay? If it's going up, it's a positive angle. If it's coming down, it's anti-clockwise. Sorry, it's clockwise. Then it's a negative angle here, right? The negative shows that it is below the horizontal line, right? So this answer. Okay.